All right, so another special right triangle that we like to work with in trigonometry is the 30, 60, 90 triangle. And for these, to see all the geometry of where it's coming from, we start with a equilateral triangle. And in this case, I have a triangle with sides 16 that has all of the angles are going to be 60 degrees because equilateral means also equiangular. And we're going to start by drawing a perpendicular bisector, meaning we're going to go from one of the vertexes to one of the sides, and it's going to be both perpendicular and bisecting, meaning it's going to cut it in half. So if we look at this, we're going to draw that, and then we can put a point there at where they intersect, and then we can see what it's 90 degrees, so perpendicular. And then if we measure it, we can see that this is now 8 units long. So I have still a 30, 60, 90 triangle. And if I look at it, the hypotenuse and the shorter side, because it's going to be opposite the smallest angle, is going to be half of that hypotenuse. So we have that relationship for the 30, 60, 90 triangles, that the hypotenuse is going to be twice the short side, or the short side is half of the hypotenuse. And we're going to use that with the Pythagorean theorem when we work at that. Now, the 30, 60, 90s are even more interesting as we go with that. So if I take one of the small triangles and I draw a perpendicular to the hypotenuse from the 90-degree angle, what's going to happen is I'm going to make a perpendicular. And when I look at the measurements there, I will have it's down to 90 degrees. It took me a little bit to get there. And now I have this side is 4 units long. I remember that the hypotenuse of this little triangle, this little right triangle, is 8. So I still have a 30, 60, 90 triangle, and the short side is half of the hypotenuse. So we're going to do a Pythagorean theorem with this, going into my other system yet again, and we will be switching screens. Okay, so I have my 30, 60, 90 triangles moved over to where I can draw. We're going to start with what we know. So in the original one where I drew the bisector, I have, whoa. All right, so watching my desktop, as you can see that it's a busy. Anyways, being careful with what I touch. I have my hypotenuse is 16, and we know that the short side, when I measured it, this was going to be half of that, so this is 8. I can use my Pythagorean theorem to find my tall side, so I'm going to call this, I'll just say B. Um, and we know our Pythagorean theorem is going to be x squared plus b squared equals 16 squared. Going and working with the numbers that I have, I can figure out actually what my numbers are. So we're going to look at the 8 squared is 64 plus b squared equals 316. Double checking that my 16 squared is correct. So 16 squared is 10 plus 6 times 10 plus 6, 100 plus 60 plus 60 plus 36. So 220 plus 36 is 256. So I have the wrong number. I have a cube in there instead. So we will fix that. Just to remind ourselves that multiplication is always good. So 256. Erase all of that because I'm going to need that space. All right, so finishing and solving. One thing that I do with videos, I usually will fix my addition things, but mistakes do happen. So hopefully I'll catch them. Sometimes I don't, but please let me know if I miss something. So I'm going to subtract 64 from both of these. I get b squared equals 192. not liking using these numbers, so we're going to look at something later for how we could have made this easier algebraically as opposed to finding the numbers as if we were using calculators. So this, yet again, solving for it, we're going to square root both sides. And then we're going to have to find our perfect squares. So using numbers, not always the best thing. I don't mean to write the squared. And then 192, I'm going to have to think of what perfect squares go into 192, working a little bit backwards. I know I'm going to have a square root of 3 here, so thinking with that, I do know that 19 is 3 times 64. And then I can break this down into my two square roots. So b equals the square root of 64 times the square root of 3. And so b itself is going to be b equals 8 square root of 3. So the sides of a 30, 60, 90 triangle will be the short side is half the hypotenuse. The long side is square root of 3 times the short side. You can memorize that. I find it's much easier to just do the Pythagorean theorem, just remembering the one fact that the short side is half of the hypotenuse, or the hypotenuse is twice the short side, whichever way you like to do that. I think in fractions, so that's how I work with that. Working with the other one, we're going to look at some of the algebra that we could do instead of having to find those actual numbers to make life a little bit easier when we're simplifying things. So in this triangle, this time they give me the short side, and that automatically will tell me that my long side is going to be 8. And then this is, my hypotenuse is going to be 8, and then my long side is going to be b here. Doing the Pythagorean theorem yet again, I know that 4 squared plus b squared equals 8 squared. Now we're going to think about this slightly different. 4 squared, that is what I can deal with. That is the same thing as, you know, 2 to the 4th. But I don't really want to deal with that. So I can really think of this 8 squared. How can I break that down? It is thinking about 8. So this is the same thing as 2 times 4. And it's still squared when I'm thinking about that. Since I'm multiplying, I could deal with each one of those, and this will become dealing with the exponents when we're looking at that. This would be the same thing as 2 squared times 4 squared. So I have 4 squared plus b squared. And then I'm going to subtract my 4 squared. Minus 4 squared. That is minus 1 times 4 squared. So that will be b squared equals 3 times 4 squared. And then if I square root that, it will get me back to that square root of 3 times the short side. Yeah, because when I square root both sides, I'm going to get b. Remember, it's a distance, so I don't have to do the plus or minus because it's going to be the positive. So this is the square root of 3 times the square root of 4 squared. So b equals 4 square root of 3. Now, that is all said and good. We can find, if we are only given the long side, we could do the same thing. So we're going to erase some stuff here. Basically what I just did. Because I have a feeling you're going to probably want to just use what we've done before, and with the numbers. They're not going to be terrible numbers. However, we can use our properties of algebra to work with things. But in this case, I do, if I can actually erase this, I do want to actually think of what are we going to do when we have the long side. So I'm going to erase this, and then I'm going to actually get rid of the labeling, make this disappear. And so now say we have the long side, and let's give ourselves a decent number for the long side. I don't want a huge number, don't want a small number. I'm going to call it 6, just because I can. All right, so if this is 6, I can still use the concept that I have of the short side is half the hypotenuse. I'm going to call this, or the hypotenuse is twice the short side, whichever way you want to do it. Probably you're going to want to call this x, and the hypotenuse is 2x. And once we have that labeled, so as soon as we can label all 3 sides with one variable and numbers, you can always use the Pythagorean theorem. If you can't use just one variable and numbers, then you can't use the Pythagorean theorem, and we'll have to use different ways to find the sides of the triangle, but we will get there. For right now, this is what we've got. So Pythagorean theorem is going to be short side, so x squared plus long side squared equals the hypotenuse squared. Okay, so we have x squared plus 36 equals 4x squared, because 2x times 2x is 4x squared. Get the x's together, so I'm going to subtract the x squared. And then I have 36 equals 3x squared. I want to get the x squared by itself, so I'm going to divide by 3. So I have 12 equals x squared. And now I have to square root both sides. And that will give me x. And square root of 12, I need perfect square. The biggest perfect square that goes into 12 is 4 times 3. So this becomes the square root of 4 times the square root of 3 equals x. And then x equals 2 square root of 3. Now, going back and labeling our triangle with that, that means this side is 2 square root of 3, and the hypotenuse has to be twice that, so that will become 4 square root of 3. All right, so all one color with my work, but hopefully that works with that. One last thing that we want to do with our our 30, 60, 90 right triangles is, what do we do for our special cases? We are going to erase all our work here. Going back to what we had, just so that I have more space. And this time we're going to talk just as a precursor for when we start looking at the unit circle and how things map onto right triangles or onto the coordinate plane. I'm going to erase this a little bit, erase too much, make my picture look better. Not that it really matters. Okay. So this case in time, we're going to get a very generic one when we're looking at things, and I am going to call the hypotenuse, because I've got the hypotenuse. And if I call my hypotenuse 1, what are the other sides of my triangle going to become? This will become 1/2, because it's half of that, which means I'm going to be dealing with a fraction. And this will be b again. And then my Pythagorean theorem, I'm going to do a slightly thinner pencil. And I will start with this color. So in that case, my Pythagorean theorem is going to be 1/2 squared, short side, plus long side, which is b, equals the hypotenuse, which is 1 squared. Okay, doing my math, 1/2 squared is 1/2 times 1/2. You multiply, you square the top, you square the bottom. So this is going to be 1/4 plus b squared equals 1, because 1 times 1 is 1. And now I have to solve for b, so I need to get rid of everything else. So I'm going to subtract 1/4 from both sides, minus 1/4. I'm going to change this, is going to become 4/4. So I'm going to change this to 4/4 minus 1/4. So this is going to be 3/4 equals b squared. All right, so this is where I say fractions are very important. They make your life a lot easier the more you can understand that. We will have videos for how to deal with fractions, and there's a reminder for all that arithmetic without a calculator um, later. So now I'm going to square root both sides. So if I square root here, remember if I square root a fraction, it's the same thing as square rooting the top and square rooting the bottom. So this will give me b equals the square root of 3 over 2. So that worked a lot nicer. I don't have to rationalize the denominator. It's already there. And then that is how the ratio of a 30, 60, 90 triangle is always going to be. If the hypotenuse is going to be 1, the short side is half of that. And the long side is going to be square root of 3 times the short side.